Hello YouTube, Brandon here with BitBionic, and today I want to cover off how we can run a Keras model inside of a native C++ TensorFlow application. Now if you've ever done any Keras programming in the past, you probably know that the models that get saved out are natively an HDF5 model, and that TensorFlow works with protocol buffers. So what we'll do in this tutorial is build a simple CNN in Keras, and then we'll save out the HDF5 model. We'll convert that to a protocol buffer, and then we'll test all that through the Python tooling. Afterwards, then what we'll do is we will build a TensorFlow C++ shared library, and we'll link all that together, and you'll be running natively your Keras trained model inside of a native C++ application. This is going to be a bit of a long tutorial, but if you're interested in this, then stick with it and we'll knock it out. Now I do have detailed instructions on my blog, and then I also have on my GitHub repo, I have all of the code files that we're using here. So in fact, I would encourage you, if you want to follow along, to go ahead and clone this down. That's what we'll be doing, and then we'll run from there. So to start with, I should mention I'm doing this on Linux, and this should also work for Mac. On Windows, I have not tested this out on Windows, although I will say that I was not able to build, I struggled to build TensorFlow on Windows. I was able to get it to build using CMake, but I wasn't able to build a shared library with it. I was able to generate projects, Visual Studio projects with it, and you could hack around on those Visual Studio projects. So if you're on Windows, you'll probably have to dig a little harder. And if you get that figured out, I'd love to see a tutorial on it. That'd be awesome. Shoot me a link. All right, so to get started, what we're going to do is let's just grab the data set first. And so the data set we're going to use is from tensorflow.org. It's just their example image data set with their flowers. It's what they use on a lot of their tutorials. So you can just follow this link. I'll have it in the description below, along with the link to the blog and to the GitHub repo. It'll be about 218 megabytes when you download it. I've already downloaded this, so you can click on it and go ahead and pull it down. When you download it and unzip it, you're going to end up with the flowers directory, and inside of that you're going to have training and validation sets. You're also going to have these labels. The labels are just the list of categories for the images. And so this is the data we're going to end up using. Now the next thing that you'll want to do is you'll want to go out and clone the repo, the GitHub repo. So you can go out and you can clone or download it. Either download the zip of it or use Git to grab it. I've already, of course, got that. So we'll just start there, and you can see that I was doing some of this before. Ran into a small problem with my recording software, and basically we're starting over. All right, so what do we have here? We have a bunch of these K2TF files, and the first one is basically to generate our model. All right, and it's very simple. The model we're generating is just a simple CNN. I've got 3 convolutional layers in here, max pooling and padding in between, and then we flatten it, and then we add a dense connection layer, and then we drop that layer down to our categories with softmax activation on it. The thing to note is one, that we're applying names to all of the layers, and that will come into play when we actually do our model conversion. And then so just make note that we have all of the names on the layers. All right, so let's go ahead and check this out. Let's run it and let's see what it looks like. All right, so TF trainer.py, and if we just look at the help on this, it'll give us our arguments, right? And the required arguments are our test, our train, and the number of categories. And then we can tell it where we want to put the resulting files. We can give it a batch size, number of epochs we want to run. Of course, there's some defaults for all of that. And then if you want to change the shape of the input, right now it defaults to 128. And in fact, I did change the shape on that. If we go down here and we look at the command I ended up using, I'll just grab this and pull it up. It'll be a little easier to read. Let's go back here. All right, so let's look at how we're doing this. So we're calling the trainer. We're pointing it to our test data. Again, this is the data flowers. So our test is our validation set. Our train is the training set. We've got 5 categories. There's 5 different types of flowers in there. And I'm downsizing this down to 80 by 80. It works for this example. I also have a batch size of 120, and then I just threw a ton of epochs at it just to get something out of it. And I dumped that all into the temp folder inside of this cloned repo. So after running that, and that shouldn't take too long to run if you've got a GPU on your, if you're using TensorFlow GPU, then it should run fairly quickly. So after we run this, we're using model checkpoint in the script to dump out anytime we get a higher validation accuracy. So you can see that some of my higher validation accuracies for this were, between 83 and 86%, which, isn't going to win any awards, but it's, it's good enough for what we're doing here. And so then what I was looking at is, okay, well, what's my lowest validation loss? And in fact, this is it. So 83.7% with this validation loss. So that's the one we're going to end up using. And before I end up going and converting it, I wanted to smoke test it. So also in the repository is this K2TF eval. This K2TF eval literally just kind of takes your model and you can throw an image at it and it'll give you the predictions out on the other end. We can take a quick look at that. It's very, very simple. I mean, this is the whole sum of the program right here. And most of it's the options parsing. So we grab the options parsing. It's using the class indices. If you notice, part of the trainer dumps out these class indices. So these are the labels of the different categories and their associated indices. Now, if you train against a different data set other than the flowers data set, then this will be different. And I've accounted for that in the script. If you train for a different data set, you can just use this labels argument and you can pass in the indices.txt that you used for your training, and it will, it'll go ahead and make use of that. So it just loads in the image and dumps it into your model and then spits out the results. And so we can take a quick look at that. So this is eval. And let's look at this. So it takes a model, right? And we just looked at our model. So let's grab our model. I'll take this guy. All right, and it's going to take an image. Well, actually, let's pass in the size. So I had a size of 80, and then it's going to take an image, and we just saw our image data over here. So our image data, let's use a validation set so it didn't train on it. And let's grab a dandelion, throw this dandelion at it. Now, if you train on a different data set, then you would also want to pass in the labels parameter and point to the indices.txt that got output by that. But since we're training on the flowers, then this will work fine. All right, and here's our output. It said 99% dandelion, and then everything else is sub 1%. And just to make sure that we're not, we're not getting lucky, let's go ahead and run on another chunk of data. So let's try a rose picture here. Let's see how that comes out. Whoops. Well, that sure is rose. All right. All right. and it's 99% roses. So, based on a sample size of 2, I'm confident in my model. And now I want to proceed to convert this over so that I can use it in a pure TensorFlow application. So the way I'm doing that is we have another script, this K2TF convert. And, I actually took the script, I adapted something I found online, and I thought I had it up here. Apparently I don't, but I do have a link inside the script, so we will grab that. Right. So I want to make sure that, let's give credit where credit's due, because I did not come up with this on my own. Oh, here it is. That's funny. All right. So this GitHub repo, Amir Abdi. Hopefully I said that right and didn't butcher it. But he has a Python notebook out here, and he in fact wrote the script to take the .h5 files and convert them over to .pb files. And so what I did is I basically took the code that he has written here and I parameterized it and just made it so we could run it from the command line. So let's take a quick look at what that's doing, just so we understand what we're running. All right. So we're feeding it a path to a model, and it's going to create an output directory. It's going to set the learning rate to not learning, load the model, and then based on the number of output layers, and that's important, not number of outputs, but output layers, it's going to basically create an alias for those layers with the prefix name that we supply it. So we can supply it a unique prefix name like my cool output layer, and it's going to go my cool output layer 1, my cool output layer 2, my cool output layer 3 for however many output layers that we have. It's then going to serialize out the graph definition in an ASCII format, and that's useful for us to debug and just kind of double check that our naming conventions are correct and that things are in fact what we expect them to be. And then once it's done with that, it converts all of the variables to constants inside of the graph, and then serializes the graph out to a protocol buffer file, .pb file. And so that's what it is. So let's go ahead and do that. And in fact, last time I tried this, I didn't want to overwrite my files. Oh, but here it did. So I'm just gonna, be brave and do this on the fly. All right. So K2TF, and then we want to convert, right? And my feeble mind has already forgotten all the arguments, so we're going to go ahead and take a look at those. All right. And so the first thing we need to do is hand it the model, and we know what that is. And number of outputs, I have a single output layer, so that's just going to be 1. And then I want to, we could dump it out into its own output directory. We could also change the prefix name. This prefix name, it'll work fine. So we'll just leave everything else as the defaults. I do want to mention that for the prefix name, you do want to choose something that is not likely to collide with another name in the graph. So a name like output might not be a good name, just because there's a very high likelihood, especially if you're using a pre-built graph from like Keras.applications, if you're using their inception model or something like that, there's a high likelihood that there might already be a node in there called output. So you want to use something that, think of it like name spacing, where you want to, try to prevent collisions. I really doubt anything is ever going to be K2TF out, so we'll go with that. All right, and so it pulled it in, And here you can see that it generated the output nodes since it was just one. There's this K2TF. It wrote out our protocol buffer file. It converted 10 variables to constants, and it wrote out an ASCII file for us to look at as well. And, I mean, we can take a quick look at the ASCII file. Here's our ASCII file. Something to note is our first node here is our input. And if you noticed from our file before, when we trained our model and named our first node firstconv2d, right? And when we come back here, we can see that our input node is firstconv2d underscore input. And that'll become important here in just a moment. So then the other thing that we did is we said, hey, I have a single output layer and we want to alias that. So let's look at our K2TF. And here it is, here's our single output layer. And if we followed this chain of this input, we would find that that trails off to our actual output node as well. So this just kind of acts as an alias wrapped around it. I think that's my impression as I was reading the documentation and how the code was working. So let's use this now. So now we have our protocol buffer file. We should be able to use this in a pure TensorFlow application. All right, so now that we have the output graph.pb file, we should be able to use the TensorFlow example files to generate, to actually make use of that. So we should be able to use labelimage.py or the main C++ here. We should be able to use either of these with the model that we have. And so what I did is I just copied these files into my GitHub repo, and we'll play around with those and verify that actually works. All right, so let's go back to our code here and let's take a look at the labelimage.py. What you'll find is that this is very similar to the eval program that we ran earlier. We just send it our graph, we send it our image. We need to point it to the labels, although this time it's the labels that were provided with the flowers dataset, and we'll hand it the width and height of our image, and we have some new parameters here that we'll work with, and that's our input and output layers. So let's go ahead and work with that. And I've run this before, so I'm going to just jump down here and grab our command line string, and then we will, oops, that's not the right one. Here we go, labelimage.py, and we'll just grab a sample here. And let's just bring that up and take a look at it. Right, because I mean, our goal here is just to prove that the protocol buffer file is in fact working, and so this is not using Keras at all. So here we have, we're calling the labelimage.py. We're handing it our output graph that we just generated. We're handing it the location of the labels file. So the labels file we're talking about here is this labels.txt. Right, that's got daisy, dandelion, roses. And if you did not train on this data set, you can generate this simple enough just by going to the indices.txt and pulling those out in order, and just generating a labels.txt there. And so then you can point to that. And so we also adjusted the width and height to 80 and 80. And then we have our input layer. So this is new. Right, our input layer. And if you notice here, this is first conv2d, right? So again, if we go back to our training, our first layer here was first conv2d, and that is in fact our input layer. And we could verify that by looking at the ASCII file. And then our output layer is the output layer alias that we created, this K2TF out underscore 0. And then we're handing it an image, and this one is in the dandelions folder. So we'll go ahead and run that. And here we go. We got a 99% on the dandelions. So we could, on the blog, I've run this a few more times against some other data, but in general, it's working. So if you're not interested in the C++, then we're done, right? We've transformed the data model over into a protocol buffer model, and now you can use that in your Python TensorFlow applications. If you are interested in the C++, then what we'll do now is we'll actually attack that problem. So the first thing we need to do is we need to get hold of the TensorFlow code base. So we'll just pull that from GitHub. And I believe I have that up here. Oh, we can use it right here, right? So the first thing we'll do is we'll just clone down this repo. And I'm going to do that inside of our tutorial directory because I have other links set up that are relative links, and you'll see those when we go to build out the C++ stuff. So let's just do a git clone and then just add that guy in. And we'll just leave it at that. All right, so that's done. Now, as I mentioned before, TensorFlow uses Basil as its build tool. I think I mentioned that before. TensorFlow uses Basil as its build tool. And so we will need to install Basil. So, TensorFlow.org has an install with sources directory, which, kind of gives you everything you need to get going here, but we'll walk over it. Here's something we did not do. So we went ahead and we checked out TensorFlow. However, we didn't go to a particular branch, and I want to do that just because I trained with version 1.1. So I want to just make sure that git check out our 1.1. Oops. Oh, I've got to be in the directory. Here we go. All right, so now we're switched over into the branch, and notice I did jump into the TensorFlow directory. But in order to build, we need Basil, we need the Python dependencies, and then if you need to build GPU, then you need those dependencies. I'm not going to do the GPU here. I wanted to build a shared library, and I didn't want downstream users to have to worry about having an NVIDIA or CUDA environment set up. So we're just going with just the Basil and the Python dependencies. So on installing Basil, and again, this is for Linux and Mac, we're going with the Ubuntu path here. There is, an install OS X link here, and you certainly can follow those directions if you're on Mac. This is pretty straightforward. So the first thing we need is Java 8. I already had that installed. If you don't, you can either use the Oracle or the OpenJDK. I am using the OpenJDK. And then next is adding this repository. So if we just grab this will add an apt-get repository to your environment. So you just run that through your command line. And then next, standard sudo apt-get update, and then apt-get install Basil. So that's all there is to it. And I went ahead and ran that. That's already been done. Once you do that, you can check your install by just saying Basil help. And you should get some feedback rather than it just, getting upset with you. So there we go. We have Basil installed, and we've grabbed TensorFlow. The other thing that we need to do is grab our Python dependencies, and this is going to be, slightly depend on which version of Python you have. I have Python 3.5 or 3.6 installed, so I'm using, the Python 3. We're installing NumPy, Python dev, pip, and wheel, and you can do that. The only difference here is one of them uses Python 3, the other one uses Python. Again, that's already installed. The other thing that if you haven't compiled C++ before, Hopefully you have if you're trying to follow this tutorial, but if you haven't compiled C++ before, you'll need your build tools on your in your environment, and that means that you'll need like GCC, G++, and normally you do that with on a Debian system. You do that with sudo apt-get build essential. I said Debian. I'm not sure if that's true for Debian. I know it's true for Ubuntu and Mint. So kind of making the assumption that it goes back to Debian, but that might be a wrong assumption. All right. So that gets us everything we need to get going. So now that we have that, we're ready to build. And for us to build, the first thing we need to do is configure. So there's a configure program built in here. We just type configure. And for these purposes, I just go with the default on everything, but it's going to ask me where my Python is, where my Python libs are, and it tries to detect that ahead of time. But I'm just literally going with all of their default arguments. So there'll be no CUDA, no just-in-time compiler. There won't be OpenCL support. I'm just kind of going with plain vanilla. And when you're doing this, it's going to sort of act like Maven. It's going to reach out and go grab, different dependencies and pull those down. All right, configuration's done. So now we should be able to go ahead and do the build. So I'm just going to go ahead and put the command line here for the build. And this took me a little bit of Googling and kind of slicing and dicing information I found around. Most of the time, most of the articles I found for building with Basil were actually building the pip package, the Python pip package. And that wasn't the target I wanted to hit. I actually wanted to hit the shared library. I found it, and I'd be interested to know if someone out there knows how to actually list available targets through the build system. I couldn't find a way to do that. But what I did do is I went into the TensorFlow code here, and I went into these build files, which are the configuration files. And inside of the TensorFlow build, at the bottom of this, I found two of the binary build targets. I found this lib TensorFlow _cc.so, which seems to have a whole lot more stuff bound to it. And then up above, I found lib TensorFlow.so. So I've built both of these. They both seem to be valid targets. Since this one seems to have more things bound to it, I went ahead and chose that to build for this round, and it seems to work well. So that's how I came up with this. So real quick, just the other arguments here. Jobs is just if you've got X number of cores, you can throw multiple jobs at it so that it builds a little faster. I turned on verbose failures. This turns on optimizations, this -c opt, and then there's other optimization options here. So I'm doing AVX optimization, floating point math optimization, and then MSSE 4.2. So you don't necessarily need those. You can clip those out if you don't want them, or if you don't have them available in your system. All right, and then we can just go ahead and hit run, and we'll do this, and you can probably go get a cup of coffee or breakfast, or go shopping or something, because this will take a little while. Takes a few minutes to build this out. Okay, we built, and we are in the home stretch now. So after that built, if we go, must have closed the other window. All right, after that built, if we go over here to our, where is it? YouTube tutorial folder. If we go into the TensorFlow, you'll see we have these new directories, and one of those directories is Basil bin. We go in TensorFlow, and you'll see now that we have lib TensorFlow.so. So there is our shared object library. All right. Now we need to hook that up to the C++ application. And we can take a quick look at that. So again, this is the application that came from TensorFlow examples. And it performs the same operations that the Python application did earlier in the tutorial. So if we go down here to the bottom, you'll see all of the input flags, again, image, graph, labels, image width, or input width and height, and the input output layers. So those are all the exact same. So now we should be able just to go ahead and build that. When I first did this, I did this with, I put all this together in Qt Creator, and but I didn't want everyone to have to install that file. I did want to show you guys what the configuration looked like though. So the configuration basically had TensorFlow on the include path, and then some of these dynamically generated files because you know, through the build operation, a lot of these files get dynamically generated. So these are the folders you have to include, and then as far as linking, of course, we have to link to that to the lib TensorFlow CC folder, and then otherwise the only source file is the main. Now I did include a build script, and that is this guy. So here's the commands. I broke it out into 3 commands. The first is to build the object file. The second is to link the object file to the library. And then the third is to copy the library up into this directory. So we can execute that file locally. So I'm just going to back up to our repository folder and then execute that build script. And that will just reach out and execute the main.cpp and then link it. And so now if we look, you see that we have the lib TensorFlow libraries there, and we have this executable, this tutorial executable. So if I run tutorial, you'll see that it's looking for some you know, default inputs that just aren't there. If I throw something at it that it doesn't understand, then it dumps the help out, and of course now we can see the help. And so let's just go and let's try our standard test that we've been running. You know, so I'm going to go grab one of the ones I've already run. There we go. So we have tutorial. Again, we're pointing to the graph, we're pointing to the labels, we're, you know, setting our input and width and height to 80 and 80, same input layer, same output layer, and then we point to an image, and we're back with the dandelion again. And you see that spun up incredibly quick, but there we got 99% on our dandelion, so it's working as well. So that's it. That's everything running from end to end. Hopefully this was good for you guys. I hope you guys you know, got something out of it, and I really enjoyed learning about it. And if you like this, please subscribe to my channel, or at least click the like button. And until next time, enjoy your programming.